Hello, my name is Claire Strobel. I'm one of the interns for the N3 Summer Research Program, and with the help of my mentor, who is a postdoctoral scholar in astronomy at the Infrared Processing and Analysis Center at Caltech, I've conducted a research project on the identification of galaxies with peculiar spectral energy distributions in a sample of galaxies in the cosmos field. The purpose of this summer research project was to analyze a large table of spectral energy distribution data collected for a sample of galaxies in order to find the outlier of spectral energy distributions in that dataset. Computer programming methods, specifically the programming language Python, were used to perform this analysis. It is important to note that there are three main morphological galaxy classifications. There are spiral galaxies, such as the Milky Way, elliptical galaxies, which take on a more round, uniform shape, and irregular galaxies that do not fit into the previous two classifications. The dataset we will be analyzing contains galaxies from all three classifications. The color emitted by a galaxy can be represented by the electromagnetic spectrum. Color depends on the radiation emitted by a certain wavelength of light. Spectral energy distributions are a way to measure this emitted radiation. Fluxes measure that amount of radiation in the unit of time. In the example SED pictured, you can see that the x-axis represents the electromagnetic wavelength, while the y-axis represents the power of the radiation emitted in that wavelength. The dataset, which is also available in the larger NASA IPAC extragalactic database, is known as Cosmos 2020. Cosmos 2020 has data for over 1.7 million galaxies, but for the purpose of this project, only a subset of the data, containing about 60,000 of the galaxies, will be analyzed. The dataset contains numerical values for 7 different fluxes for each galaxy. Each flux is different because it was collected using different filters, which each process only a certain wavelength of light. This data was collected by several telescopes in a certain field of the sky. The spectral energy distributions in this dataset were classified using a machine learning technique known as the self-organizing map algorithm. It is used in dealing with complex datasets to simplify and organize the dataset. For this dataset, each galaxy was assigned to one of 100 cells based on similar SED data. The programming language Python was used to write the code for this project. The Python-specific libraries, NumPy and Pandas, are tools that provide some of the techniques used in data analysis. The code I wrote was compiled in Jupyter Notebooks, which is a web-based open-source platform used to run Python code. The first criteria I used to define an outlier SED was that it must have at least 2 flux values that were more than 5 standard deviations away from the median flux value in that cell. I say that it is the first criteria because it may need to be refined or changed upon further research. The specific code I wrote is mainly a function that takes an input of a specific cell in the dataset, so a value between 1 and 100. The first thing was to define the table of fluxes for which the median value would be analyzed. Following this, I cleaned the data to eliminate null values and created a loop that iterated through the length of the entire dataset and extracted only the galaxies that were in that specific cell. Then I took the median and standard deviation of each of the 7 flux values for that specific cell and once again iterated through the galaxies in that cell to find which met the criteria. Aside from the main function, I wrote a secondary function that would output a list and number of the outlier galaxies in a range of cells, say from 1 to 10. For the entire range of cells, 1 to 100, it was found that there were 295 outlier galaxies using this criteria. However, changing this criteria may change this number, and we need to take a closer look at the SEDs and images of these galaxies to finalize this criteria. I wrote a code to select 4 random galaxy IDs from these 295 outliers so I could display their images. The research I conducted is part of a larger research project that will be continued. Upon further research, there are several things to consider and work on. One is more accurate cleaning of the data. Additionally, as the code was written specifically for iterating through the given subset of the Cosmos field, it would need to be edited for use on other datasets. It should also be checked to maximize efficiency, which is of great importance when working with even larger datasets. Perhaps the most important thing to focus on is the analysis of the outlier galaxies that this code selected. These 295 galaxies out of a data set of over 60,000 should be looked at more closely to determine specifically why they are outliers, whether there is something wrong with the way their data was collected, or whether there is really something peculiar about them. I would like to thank my mentor and the coordinators of the N3 research program for making this project possible. Thank you.